In this video, I'm going to introduce the fundamental identities. Next to the just straight definitions of our 6 trig functions, these are the identities we use the most in trigonometry. You will need to know these. These will never be provided on a formula sheet. We have 3 Pythagorean identities. Sine squared plus cosine squared equals 1. I feel like that's the big one. That's the one I use the most. That's the one that I have memorized. But we do have 2 more Pythagorean identities. Tangent squared theta plus 1 equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta. These identities are derived from our relationship that x squared plus y squared equals r squared, right, which comes from our Pythagorean theorem. If I take this x squared plus y squared equals r squared and I divide each term by r squared, I get x over r squared plus y over r squared equals 1. And by definition, x over r is cosine, and y over r is sine. So this brings us to cosine squared plus sine squared equals 1, which is that first Pythagorean identity. I just have it in a different order there. We can derive the other 2 Pythagorean identities just by dividing by something different. If we divide through by y squared, we'll get this one with the tangent. If we divide through by x squared, we'll get this one here with the cotangent. So honestly, I only have the first one memorized. It's the one that we use the most. If I find that I need the other ones, well then I just derive it quick by doing the division. Next up are our quotient identities. Tangent of theta is equal to sine divided by cosine, and cotangent of theta is equal to cosine divided by sine. I'm going to do a little proof here for you of this one here. So if we start with sine of theta divided by cosine of theta, sine of theta is defined to be y over r, and cosine of theta is defined to be x over r. I'm going to rewrite this by multiplying by the reciprocal of the second fraction. And when we do that and multiply, we get that the r's cancel out, leaving us with y divided by x, which is our definition of tangent. So tangent is sine over cosine. Cotangent is the reciprocal of that, cosine over sine. Again, these are super important. Definitely this one, and definitely both of these. Got to be really comfortable with them. Let's use these fundamental identities to find sine of theta if cosine of theta is equal to negative 1/4. Now, the only identity up here that relates sine and cosine directly with nothing else involved is our Pythagorean identity. So this is the one that we're going to want to use to solve this problem. Sine squared theta plus cosine squared theta is equal to 1. Remember our notation difference that sine squared is the same as sine of theta squared. And same with the cosine. This is cosine of theta squared. equals 1. We're going to plug in the value they gave us for cosine. That's negative 1/4 squared equals 1. I'm going to square that 1/4 and get 1/16. And now we need to solve for sine. I'm going to talk a lot throughout this course about, seeing the algebra through the trig. Sometimes it's hard to see the algebra through the trig because we got all these extra letters that just represent our trigonometric functions. They're not like variables that we divide by, but it can be a lot extra. So I'm going to frequently strip things down on the side to something that looks more basic so that the algebra is more easily identifiable to us. All right, so stripping this down on the side, we've got like s squared plus 1/16 equals 1, and we want to solve for s, where s represents sine. Algebraically, what we have here is a quadratic equation, and we have a quadratic equation that has a quadratic term and a constant, but no linear term. So the easiest technique for solving this type of quadratic equation is square root property, where we will subtract 1/16 from both sides. That'll give us 15/16, and then we're going to want to take the square root of both sides. That's the exact same algebraic process we're going to want to take with this trig equation. All right, so let's subtract that 1/16 from both sides. That gives us sine of theta squared equal to 15/16. And then we'll do square root property. That gives us sine of theta is equal to plus or minus the square root of 15/16. We'll simplify this radical by breaking it up into the square root of the numerator over the square root of the denominator. We get sine of theta is equal to plus or minus the square root of 15/4. I want to point one extra thing out from our directions. It says that theta is in quadrant 2. So if our angle is over here in quadrant 2, where our x value is negative and our y value is positive, is sine positive or negative in quadrant 2? In quadrant 2, the y value is positive and the r value is positive. So sine is going to be positive in quadrant 2. That means that we're only going to want the plus here. Our final answer is that sine of theta is going to be positive only square root of 15/4. Let's try another one. This time, I'm not going to use the Pythagorean identity to solve this problem. Quite honestly, if I was given the previous problem, I never would have used the Pythagorean identity to solve. I just wanted to show you one of the ways it could work. Instead, to solve a problem like this, I would draw a diagram with a triangle. You're going to see me do that a lot of times in this course. It's one of those big fundamental ideas that can be applied over and over again throughout trigonometry. So they're telling us that cosine of theta is equal to negative 3/5, where our angle theta is in quadrant 3. So I'm going to draw an angle in quadrant 3. And it doesn't matter where, just draw it somewhere. Now I'm going to drop a perpendicular to the x-axis. And you always drop it to the x-axis. This is going to create a right triangle. And here's our angle theta. I'm going to use our definition of cosine to label the triangle. Cosine is x over r. We know that r is always positive, so that negative has to be assigned to the 3 in the numerator. So negative 3 for x, 5 for r, and now we'll do Pythagorean theorem to find our y side. So y squared plus negative 3 squared is going to be equal to 5 squared. So that's y squared plus 9 equals 25. Y squared is equal to 16. And then we'll take the square root and get y to be equal to 4. Since we're in the third quadrant, our y value is negative, so this is going to be negative 4. Because we know with pure square root property, we get a plus or minus 4 there anyways, and the one we're going to want is the negative because we're in quadrant 3. Now that we have x, y, and r, we can just fill in our definitions. Sine of theta is y over r, so that'll be negative 4 over 5. Cosine, that was given, it's our x over r, negative 3/5. Tangent, that's y over x, will be negative 4 over negative 3, which simplifies to 4/3. And then the other 3 trig functions are the reciprocals. Reciprocal of sine is cosecant. That'll be negative 5/4. The reciprocal of cosine is secant. That's r over x. Negative 5/3. And then lastly, the reciprocal of tangent, that's cotangent, to find x over y. But I'm just going to take the reciprocal of that already simplified fraction, 3/4. This would definitely be my technique for this type of problem, and as many times as I can throughout trig, you'll see me do it. If I can draw a triangle, label the sides, and get my answers from that triangle, I'm going to do it.